careful. This thing's delicate and heavy. It might fall off and it's made of metal, so be careful with this. Oh, welcome to week 7, which is What is Time Part 2. So last week we discussed about our shadow clock and about watching time and watching daylight savings time occur over time and how we perceive time and how we see time. Also, we discussed that we move through time and we know that there's before and after, there's morning, noon, and night. There's all these different ways we have of talking and telling time. We also talked about the fact that we are still in a hypothesis about the tachyon particle and what it is. Does it really exist? If we find it, much like graviton with anti-gravity, do we get to go and travel through time? Which way can we go? Forwards, backwards, side to side? Who knows? Hopefully one day we'll find it and we'll figure that out. So this week, we're going to discuss what makes the difference between day and night. We know day happens, we see day happening. We know night happens, where are you going? I'm not done yet. So, we know that there's day and night, but what's happening out there in space during day and night? What's happening to our Earth as this is going on? So, last week we discussed that there's an axis, which is an invisible line that moves through the center of our planet, and around that axis we are rotating. So we're in this massive state of rotation that's going on, and that's why the sky looks like it's spinning at night. I mean, it's not fast, but it's really slow. If you put a telescope up there and you look at a spot and you keep it locked on that spot, over time, your telescope's going to be looking at a totally different area of the sky. So during this rotation, those Babylonians back in the day felt that it was approximately 24 hours, and they were so close. Modern technology and the way that we actually can measure in our mathematics have improved a huge amount. And we've actually been able to figure out that our Earth spins at about 23 hours, 56 minutes, and 4 important seconds. Is that 24 hours? No, it's not a full 24 hours. Which is why this year, which you would have experienced it last school year, man, it's a lot of ways of telling time here. We had something called a leap year, which comes around every 4 years. And in that leap year, we add an extra day to our calendar in February, I believe. So you just get to add an extra day? Well, it's because if we keep our hours and our time at 24 hours because it's easier for us to manage, then every 4 years we see that we would need to add an extra day to make up that tiny bit of time that's left over on our actual rotation time throughout the day. So if you really want a cool math problem, you can take this 3 minutes and 56 seconds and multiply it by the number of days in a year, and then multiply that by 4 and see if it equals about 24 total hours. And that will tell you why we get to add an extra day during a leap year, which happened this year, which was last school year, as I said earlier. Lot of time moving around everywhere. Oh, wiggly. So during the day, that is when the sun is shining on this side of the Earth, but the other side of the Earth, it doesn't get any sun on it. It's in that shadow. So much like our shadow clock, where we have our stick in the center and it casts the shadow on the other side, the Earth acts like that same stick. So the other side is all shadow. The light can't go through the Earth and shine through the ground on the other side. It's just dark over there. And then when it's nighttime here, guess what the people on the other side are doing? They're having daytime. So we're over here at night and we're taking our naps and sleeping, and they're up at the beach hanging out right in the middle of their day. They're having a great time. So we all don't sleep at the same time. We sleep based on where we're at on the planet and where the sun is in relation to where we're at. So when we tell time, you'll notice there's 2 little letters that'll often follow it. There's an AM and a PM. Now, we usually just say AM's in the morning, PM's in the afternoon, but it's a little more complicated than that, because what happens if it's 10 o'clock at night? Well, is that always PM? What happens if it's 3 in the morning? It's dark out, so we usually say PM is dark because we wake up when the sun comes up, and that's AM, but it's a little trickier because sometimes 2 o'clock in the morning is still dark. We use AM. So when we look at our clock, the Greeks had this great thing where they watched the sun. So when the sun reaches the highest point in the sky, we call that the middle of the day, or the midday. So the sun will rise in the east, go through, have its highest point for the day, which is midday, and then set in the west. So the mid is the middle, and they use the cool word called meridian. So that's what the M in PM and AM is. It's for meridian, which means the middle. And they got the middle at the way the sun is at the highest point in the sky, but at night there's no sun on this side of the globe, but on the other side, they're right in their midday. So that median, that line that goes to the center, is for both sides. And then if you're on the earlier side of it, which would be your morning when the sunrise is going to happen, that's called anti-meridian, or before the middle. And as it passes that midday sun and it starts to go down on the afternoon, that's called post-meridian. Post, like post-game, happens after a game. So you have your AM with sun rising in the east, and PM with the sun setting in the west, and it's getting all sleepy and tired as it wants to go to bed. So we're going to take a look at an orrery so you can actually see that in action with a device that was, I believe, also made by the Greeks. It's totally cool. So this device, which the Greeks invented and it got just built on and built on, then the technology was lost, is called an orrery. And an orrery has the sun with a light inside, and that light is focused on the Earth. So this is our Earth, and it has all of the continents on it, and they're all labeled, so it's just like a globe that you would have in class. So what it does is, as I move this mechanism, it spins, and you can see how the daylight on one side and the night on the other, and how it breaks right in the center, splitting our sun, or our day in half, with half daylight and half nighttime. And as I move, you can see the different continents spinning around. And this is a really fun device. We get to look at a lot of different things with this. There, and that's our orrery. So hope you enjoyed learning a little bit about time. There's so much more to go on. We are still learning a ton about the way time works. Till next week, bye.